Rootstock is a layer 2 EVM compatible blockchain which sits on the Bitcoin. It lets you deploy NFTs on the Bitcoin layer, and in this video I will show you how to write, deploy and mint an NFT on Rootstock in just 20 minutes using just Remix and your browser. There are no local setup needed, so let's dive into it. Yo guys, so the first time I came across Rock, the idea that stuck with me was the fact that you could build and deploy smart contracts. But now we're doing that on the Bitcoin layer. I mean, that was really amazing for me. And it caused me to it sparked my inquisitivity if you want to know how things worked under the hood. And so I later discovered that Rootstock is a Bitcoin side chain, technically an EVM compatible chain. And it's a layer 2 blockchain, which supports Ethereum smart contracts. So it gives the security of Bitcoin with the flexibility of EVM. I mean, that is just so freaking cool. And this makes it perfect for launching NFTs. I mean, when you want to launch your tokens or NFTs, you want really infrastructure. And Rootstock really has that infrastructure. Compared to Ethereum, Rootstock offers some benefits to developers building on Rootstock. Some are low gas fees. Now, this means that you spend relatively low to execute transactions on Rootstock. RBTC, this is the native token of the Rootstock chain, and it is pegged to the Bitcoin. This means there's less fluctuation in gas price compared to it. Also, there's low latency. This means their transactions on Rootstock are very fast. It has faster transaction speed. That is why you have to explore and build a Rootstock chain. All right, so we're going to be talking about token standards in the next video. Okay, guys, so these are the three types of token standards. We have the ERC-20, ERC-721, and ERC-1155. So our main focus for this tutorial is going to be this. For the purpose of revision, we're going to be touching the other parts. Okay, so let's start from ERC. So ERC stands for Ethereum request for comments. It's basically a type of EIP. EIP means Ethereum Improvement Proposals, and these are basically structures within the Ethereum ecosystem that help standardize things and how things are done. Okay, so ERC-20 is the standard for fungible tokens. So these fungible tokens are just like our usual cash that we spend. So fungible tokens, they are not unique, right? Any one of the token can be exchanged for anyone. So examples, we have like USDT, USDC. And because of the standard, the ERC standard, the ERC-20 standard rather, that is why you can trade USDT on Uniswap and you can trade on any other swap because those swaps make use of the ERC-20 standard. So that's how standard works. So it just enables people or everyone within the ecosystem work with that interface. Okay, now the next is ERC-1155. So ERC-1155, let me do ERC-721 first because ERC-1155 is a combination of both. So ERC-721 is not what we call the NFTs, which means non-fungible. So non-fungibility means it cannot be exchanged. So when you have one NFT, it cannot be exchanged with another because they are different. They are unique. Each NFT is a unique token. Examples of these tokens have CryptoPunks, have Bored Apes, and the different examples that we have. Each NFT is a unique token. It cannot be interchanged. There is no NFT that is identical. They could be identical in traits, in qualities, but each of them represents a unique token. Now, ERC-1155 is a combination of both ERC-20 and ERC-721. It's both fungible and non-fungible, and it's majorly used in cases where you want to batch NFTs, like in this case where you want to batch NFTs, you want to batch minting processes, and also cases where you're building games and you want a better way to represent game assets. That is when ERC-55 is used. And that is that about token standards. So in the next video, we're going to dive straight into building our NFT. So a good addition to what I said earlier is that NFTs are really good in terms of representing assets on decentralized protocols, which cannot be exchanged one for another, just like ERC-20 tokens. So if you have cases of things that are unique and cannot be exchanged one for another, examples of things like this are like pictures, assets, artifacts, things, drawings, and so many things like that. ERC-721 or NFTs are the best standards to represent things like that. Now for this project, there are no prerequisites. What we just need to do now is head over to Remix and let's do that. Right, so it should be remix.ethereum.org. Okay, learning. And then it comes with this. Okay, so let's start coding. All right. So this is the Remix IDE, and we're going to be using this to write our smart contracts. All right. So come within the, we're not going to use the script folder. We're not going to use the test folder, all of this. We're just coming here, the contracts folder, and then click this button to create a new path. So we call it NFT.so. Now let's go to Open Zeppelin Wizard. Open Zeppelin Wizard. So Open Zeppelin, it's a Web3 firm that creates lots of tools and many times implements these standards for developers to use. So you don't have to reinvent the wheel, because Open Zeppelin has created these standards, and all we just have to do is read and carefully make use of it. Okay, so this is for ERC-20. This is for ERC-721. So this has already been like abstracted for us. All we need to do is select what we need and deploy. Okay, so let me call this PEP token and then change the symbol to PTK. So from this wizard here, we can edit. So what features do we want to add? We want it to be mintable. We want the URI storage enable, yes. So after selecting those options, you can see it has generated everything for us. All we just need to do is copy it and then head over to Remix and then paste. All right, so this is basically it. It implements, we can see the standard imported, we can see the URI storage, and the constructor here basically makes the deployer of the contract the owner. And that is only possible because of this ownable abstract class. Also, it has a mint function, which is safe mint, and then the token URI function, and then the support interface function. So these are the functions that are defined in the ERC-721 standard, which every NFT contract must have. Now in the next video, we're going to deploy, but then we can compile this. Let's hope it compiles successfully. Great. So it compiles successfully. So the next video, we're going to deploy. Okay, so if your smart contract successfully compiles, you should see a green tick here, which means the compilation was successful. Now the next thing to do is to click the icon directly below it, and it should show the deployment pane here. So you can see the environment here is the test remix environment, which is the VM. Then this is also the test account. And then the contract here must be selected. Ensure that you select the contract here, which is here for this video where it's in the deploying PEP token, and that is what was selected here. So ensure that is selected. And for the deployment, we need to pass in an address which is specified here by the constructor. So we'll also not forget that. And then when you deploy your contract, we should see the contract below here, below this deployed contracts section here. But before we move further, let us add Rootstock testnet to a MetaMask. So now for us to add a custom network, we need to get the named RPC, the chain ID, symbol, and then the block explorer. So what I'm going to do is go to chain list. I'm going to copy this RPC Then I'll go to this browser and then I'll paste this here because this is the Explorer file. So I'm going to copy both of them. Now I'm doing this because I cannot, once I am filling this in a sec. So once I'm filling this, the moment I exit, I have to restart again. So I don't get two chances at once. Okay, so the name here is Rootstock Testnet. And then for our RPC, okay. So for the RPC, I'm going to paste everything here. This is invalid, that's because of this. Okay. So now we have this. So I add it. Now the chain ID here is 31. Yeah. So we can see that MetaMask already suggests here RBTC, that's tests RBTC, which is the native token for the testnet. And then for the block explorer, we'll simply paste this and boom. Very good. So we just save this. And then we can see that it has been added successfully. So we switch to testnets. So this is it. So we switch to the testnets. All right. So I have some tests RBTC. And then if you don't have test RBTC, there is a faucet. So for the faucet, there will be a link in the description to get test tokens. So now that we have switched to Rootstock testnet in our MetaMask, all we need to do now is, well, does it keep switching back? So we switch again. Okay, so let's change this, select injected MetaMask, and it should pop up MetaMask up. But I have done this, I think, when I was working on Remix previously. So it adds this. And then by default, it selects my account. All right. So one error that can happen is if this doesn't show, you might have to disconnect Remix from MetaMask. You might have to disconnect Remix from MetaMask and then reconnect it. So you can disconnect from here and then reconnect. But since it shows our network here and everything is right, so we just go ahead. So we need to copy this address and then paste it here as the deployer. And then we hit deploy. And then sign the contract creation transaction. Here, so has been deployed successfully. On the left, we can see the deployed contracts, and then Remix provides buttons which we can use to interact with the contracts. And then at the terminal, we can see view and block cloud. So let's click on that. We can see the transaction details, so the deployer's address, and then we can see the contracts cost created. So click on the contract, and then so here go to transactions tab. Okay, so on the transaction tab we can see this where the contract creation, and then this is the only transaction we have here. Now the next thing we want to do is, so we are currently successfully deployed our NFT contract. What we want to do now is mint. All right, so as you can see here, there are a lot of functions here, but right in our code we only have about 3 functions. Now what happens here is that all these functions are coming from the ERC-721 abstract contract. Now when we're using the wizard, it automatically added this. So our contract inherits from this abstract contract, which is ERC-721 implementation. Now since it inherits from this contract, it's inherited all these methods with it. So that is why we have all this here. So now, for us to be able to mint our NFT, we're going to use the safe mint function. Now, the safety function requires 3 arguments: to address, token ID, and then URL. Now, the to address is going to be my address here, and basically any address, but for me, I'm using my address. All right, so that's the address the NFT be minted to. Now, the token ID can be any number: 1, 2, 3, 1,000, 1 million. It simply ties the ownership of an NFT minted right now. To get the token URI, we need to use Pinata. Now, Pinata is let me log this out and then log in again. So Pinata is a file sharing system. It also comes in with a management and pinning services. And then it's built on IPFS. So IPFS stands for Interplanetary File System. So this is a protocol that it's a decentralized protocol for file sharing. And as the name is, Interplanetary File System. So the goal of the protocol is to be able to enable people that are even in different planets host their files on the protocol and then be able to share. Now, what happens on Pinata is that when you upload a file, that file is shredded into pieces. Now, these pieces of the file is then stored by different nodes running the IPFS protocol. But then Pinata gives us something special called CID, right? So I'm going to log in to show that. Now the CID is basically a content ID or content hash. Now we can see what it looks like. CID, yes. So this is what it looks like. Now based with this CID, when we are trying to retrieve the file, Pinata via IPFS would retrieve all the pieces or the shreds of the files on the different nodes and then build back and then build up the file that we need. All right, so what we're going to do is upload an image. So we're going to upload an image. So let's call this image. Now we're going to upload the image on IPFS. Use the file upload. Okay. So now when we upload this, we'll get a CID. Okay, it says file already exists. So I'll just change this to new pep. So the name of the file doesn't really matter here, but I think I already have an existing file name. I'll just call this new. Already exists. Okay, so let me delete this. Okay, so I'm going to try uploading the image. Now with this CID, I'm following the standard. So this standard is OpenSea standard. So to be able to generate that final URI, which is this JSON file uploaded to Pinata, we need to create a JSON file, and then it must have a name, description, image. Attributes is conditional, so we might not necessarily put this. And the image must follow this pattern. So we could either use ipfs.io/this or just IPFS. So we could just go with IPFS column/this. Now, what is here is the CID of the image which we just uploaded now, which is this. So now we paste that in, and then the name of the image and then description, whatever properties that you might want to add. Okay, now we save this and then upload that JSON file. Okay, we upload it to Pinata. Now it gives us a CID. Now that CID, we go to Remix and then we do IPFS column// then paste in that CID and then we hit transact. Let's open the terminal to see what's happening. Okay, we sign the transaction and then open the terminal. So this has been successfully minted. So we go back here and then we can see token transfer here. It updated automatically by itself. Now we have been able to successfully mint, and if we want to have a better view, we can copy the token address and then paste it here. Rootstock Block Scout gives us a better way of viewing NFTs. So we can see it here. So now it shows us the number of holders, the transfers. Now we can see the NFT with ID1 minted to this person. Guys, so in this tutorial, we learned about the different token standards, the ERC-20, ERC-721, ERC-1155. We're able to deploy NFT contracts using Remix on the Rootstock testnet. We're also able to mint an NFT to an address. Then we learned about how to use Pinata. We also learned about IPFS. And that, my friends, is how to deploy an NFT on Rootstock testnet using Remix. Want to take it further? Explore Rootstock's documentation to start building your own projects. Also, you can dive into the developer resources for hands-on support. And then feel free to join the Rootstock community to connect with other builders and opportunities that the Rootstock community offers. Links are in the description. Happy coding.